Good morning, all. Welcome to the OR class. Till now, we have completed the second model, such as the concept of model 2 are assumption of LPP, simplex method, setting up of simplex method problems we have seen, and when a tie occurs in the ratio, how to solve this one by making use of tie breaking simplex method. Then we have seen two-phase method. Then today we will see the last bit, that is the begin method. Okay, begin method is also one of the simplex method only. Here we need to perform the tabular column like we have done for the remaining concept. So the other name of the begin method is called the chance penalty method. Why we call it as penalty is that whenever a greater than equations come, that is the constraints come, in such cases we are using an artificial variable. Okay, as we have seen in the two-phase method, there artificial variable appears at the optimum basis. Then in such kind of problem we don't have the solution. In order to overcome those problems, we just want to remove those artificial variable to be appear in optimal basis. We make use of begin method. Okay, so how to solve the problems using begin method, that will be given by making use of following steps. As in the first step, similar to the two-phase method, if the problem is of the minimum type, we must convert it into maximum type. Why? Because we always apply the simplex method only to the maximization problem. So we must convert that minimum into maximization. How to convert it? By multiplying the entire equation with -1, as we already seen such kind of example. Second step, convert all the inequality into equalities. Like if it is less than, we require slack variable. If it is greater than, that time we require surplus variable and artificial variable. And in this we'll see one more type of constraint. There no less than, no greater than, only equal is there. That time you just require an artificial variable. Okay. Then in the step 3, we are going to rewrite that equation. Okay. So here the equation can be a1x, b1y, c1z. Then if the constraint contain artificial variable, then we must make assign the minus m to each of the artificial variable. Okay. Then just like in other problems we are using, if s1 s2 are there, you make use of 0 s1 0 s2. This will not make any effect to the equation, so I am not adding here. Okay. Then in the step 4, we just start iteration as we are doing in the previous examples. So we need to stop the iteration only when either of the following three cases appears. The first is if no artificial variable appears in the optimum basis and all indicators are non-negative. Then the current solution is the optimum solution. Means that we keep on solve the example until we get all the indicators are positive. Okay, then at same time we have to check that NZV column, or you can say basic variable column, where artificial variable, no artificial variable should be there. If any artificial variable is there, then it matches with the third case. Then we have to stop the iteration. We can say that the problem does not contain any solution. Then second case is, it is the rare case. So in the first initial table only, whenever we start initial table, then only all the indicators are becomes positive and one artificial variable in the NZV column, then that will be the solution. Okay, it means that only you have to solve the initial table, all the indicators are positive, then you have to check for the NZV variable. If any artificial variable is there, then stop it. That will be the final solution. Okay, next, just like in the two-phase method, here also in each iteration, whenever an outgoing variable is an artificial variable, we have to stop the, we have to, sorry, not stop, we have to drop that column in the subsequent iteration. Okay. So we start with the problem. First problem, solve the given problem by making use of the chance penalty method, or you can say the big M method. Here, the first step, the given example is in the form of minimization. So we required to convert into maximization. So how to convert it? So we convert it to maximum is equal to minus minimum. So multiply the entire equation with minus z. So minus 4x minus y. Next, check for second step. In the second step, convert each inequality constant into equal constant. So just look at the first constant. It is of 3x plus y. Here there is no less than, there is no greater than, only equal is there. So we required only artificial variable. So we write 3x plus y plus a1 equal to 3. Similarly, the second one, it is greater than, we required surplus and artificial variable. So here, just look at here, surplus variable is the minus and artificial variable is plus. Okay. Similarly, the third equation is less than, so we required only slack variable. So we made it as S2. Okay. Then rewrite the equation. Now the main change is that here both the artificial variable in the equation 1 and 2 are to be assigned with minus m. M indicates it is a big M. Then S1, S2, by default we are going to write as 0 S1, 0 S2, even though it will not write, that makes nothing, there is no difference here, that will not affect to the Z equation. Now we initialize the table, like, just look at here, in the first one, here we are going to write NZV column. In the first iteration, equal symbol plus a1 is there, so write it. The second one, only plus new variable to be added. So in the second one, a2 is there, third one, s2 is there. All three are the positive new variable, just add it here. Then coefficient, you are just writing here, it is not 4, it is only y, minus 4x minus y, 0 s1, 0 s2, minus ma1, minus ma2. Just for your reference, I am writing here. So just write this coefficient in above this table. Okay, minus 4, minus 1, a1, a2 with a minus m. Then we initially we write all the coefficients here. Then z dash equal to, multiply these two, minus 3m plus minus 6m will get minus 9m. Then get the first indicator, it is minus 3m minus 4m is minus 7m, then minus minus is plus 4, minus 7m plus 4. Similarly, second indicator minus 4m plus 1. So only these two are negative. Out of this, the most negative number, always take the m is negative, minus m. With that, I am adding 7 more negative numbers, so that by default it becomes the most negative number. Compared to minus 7m, minus 4m, take minus 7m is the most negative number. This becomes the pivotal column. Then we obtain the pivotal row. How to obtain pivotal row? Finding the ratio. XB values are 364 divided by PC values are 341. Then we get 1 is the pivotal row. In that, this becomes the pivotal key element. Then incoming variable, in the key element, incoming variable is x and outgoing variable is a1. Whenever an outgoing variable is a1, we drop in the subsequent iteration. Okay. Then perform the row operation. I am writing row operation here. So continue to do until we get all the indicators are positive. Just look at here, all the indicators are positive and we got the solution z dash equal to minus 17 by 5, and at same time no artificial variable appears at this position. If any artificial variable appears, then this problem does not have any solution, but here no artificial variable is there, the problem having a solution. Hence z dash equal to minus 17 by 5, but the given example in terms of minimum, so multiply with minus, again we get 17 by 5. Okay, then occurs at x equal to 2 by 5, y equal to 9 by 5. Then we solve the second example, z equal to 3x plus 2y. Here the given problem already in terms of maximization, so no need to convert it. Then slack variable, so plus s1, surplus variable, so minus s2 plus a1. So in the NZV column, s1 and a1. So rewrite the equation. So only minus m is the only one artificial variable, so minus m. Then write the coefficient as it is. Then keep on solving it. In the second iteration only, we got all the indicators are positive, but in the optimum basis we have an artificial variable, so this problem not having any solution. That matches with the third case. Similarly, you solve this one, it is same as that of first example. So in the last all the indicators are positive, no artificial variable is there, so the final answer is 48. Okay, if any doubts feel free to ask, so you can ping me at any time. Thank you.